Right, okay, so now let's discuss this smooth joints related problem, right? So now here we have this rod AB and rod BC, right? That are smoothly joined at B, right? And this total structure is kept on a let's say on a smooth, right? Smooth surface, right? It is kept on a smooth surface. That means no friction, right? Okay, that means no friction there. And the weight of this rod is W, and this one is 2W. So that is why I have marked the center of gravity of this rod at the mid and center of gravity of this rod at the mid, right? And both of these rods are having equal length. So this length is 2A, this length is also 2A, right? And in order to maintain the equilibrium, right? So both of these rods are attached by a string, right? Where the string is connected to the midpoint of the rod AB and in between the midpoint of the other rod BC, right? That means the midpoint of this rod, right? At the midpoint of this rod are connected by this string, as you can see there, right? So then because of that, there is a tension, right, that is developed in the string T, okay, T, right? And what else? What are the other things? Now just focus. This structure is not a symmetrical structure, right? But this structure is actually not a symmetrical structure, right? So then if this reaction is R1, if this reaction is R2, okay, definitely this R1 is not equal to R2, right? Okay. And if you are going to consider this smooth joint now carefully focus. Now this joint I am going to break. Okay, now that is the part. Now this joint, right, I am going to break now. How? Like this. Okay. This is one end and this is the other end. Now I have damaged the joint, right? So then now I am going to mark the reaction force on this end X and this as Y, right? And when considering this joint with the opposite horizontal force as on this one X, and this Y will be horizontal, this Y will be in the opposite direction as like that, right? Okay, right? So now then simply, now I have removed the two links, right, from the joint. Then I have marked the reaction forces, right? Both of these X are having the same magnitude, right? This X goes in this direction, where the X in the other joint goes in that direction, right? So opposite, right? So that's it, right? Then I can write one. You can now see over when you are going to consider the system, right? When considering the system, right? The first equation we can very clearly obtain that R1 plus R2 must definitely be equal to this W plus this 2W. That means R1 plus R2 must be 3W. That is equation number 1, right? So then let's find these reactions, right? So what can I do for that? So let's take moment about this point A. So let's take moment about this point A. At what direction should we take? We will take moments about that point A along the anti-clockwise direction, okay? What direction? Anti-clockwise direction, right? So the first we have, then we don't have to worry about R2, right? Sorry, R1, right? Because the center of acting point of these R1 and the point that where we are going to take moments will be the same. So we don't have to worry about R1, right? So taking along anti-clockwise direction, right? Okay, the first force starting from here will be R2. R2 into what is the perpendicular distance? R2 into what will be the perpendicular distance? R. Then the perpendicular distance is calculated from the distance from here to here. This angle is alpha, right? Same angle. It is given in the problem, right? The angle where these rods are making in the horizontal is same as alpha and alpha, right? So then we know this length is 2A. So what is this length? 2A cos alpha. Agree? This is 2A. So this length is 2A cos alpha. This is A. This length is this is also right. Length 2A, 2A. Wait. Now the length up to here will be 2A cos alpha, right? And then The length up to here will be again 2a cos. That means 4a cos alpha. 4a cos alpha. Agree? Right. Okay. Because when considering these force R2, don't you understand about the distance? Now this is the force R2, right? I will teach you that. This is 2a. This is 2a, right? So this is alpha. This is alpha. So 2a cos alpha here to here. Then from here to here also 2a cos alpha, right? Okay. Because in the problem it is said that these two angles are same, right? And also we know that these two lengths are also same, right? So it is an isosceles triangle, right? Right. So be very careful. Huh? This is actually here to practice. And then what is the next one is R. Then this one, this force is going in clockwise direction, so it is negative minus 2w times. Now what is the perpendicular distance? Distance from here to here. Distance from here to here. So 2a cos alpha. Here to here is it is 2a cos alpha. Then this length. See, here we have 2w, right? So then here to here we know the length is 2a cos alpha. Then from here to here will be again a cos alpha, right? Because the half the distance is a, so it will be 3a cos alpha. Right. 3a cos alpha. Anything else? We don't have to worry about tension, right? When considering the system, the tension forces are getting cancelled, right? And even this xy also, right? So we don't. Then again, we have to worry about this w minus w times what? A cos alpha. Agree? Yeah. Right? W times a cos alpha. Then R2 times 4a cos alpha minus 2w into 3a minus 6wa cos alpha minus wa cos alpha, right, equals 0, right? Because of the reason when considering the equilibrium, right, the moment about point A must be 0, right? So this must be 0. So then what? Don't worry, cos alpha we can cancel because we know that cos alpha does not equal to 0. Anything else? Yeah, we can also cancel A and A, right? So then we would be having R2 minus 7W equals 0. That means R2 equals what? R2 equals 7W, but here we have this 4 here, right? A we can cancel, cos alpha we can cancel, but this remaining coefficient 4 is there, right? That means so 4 times R2 minus 7W equals 0. That means R2 equals, that means 4R2 equals 7W, right? That means R2 equals what? 7W divided by 4 newtons. Agree? R2 equals, so you know what is R2, equals 7W divided by 4, right? So now then we can find what is R1, right? Then R1 will be what? R1 will be from this equation 3W minus R2, 3W minus 7W by 4, 12W minus 7W by 4. That means R1 will be 5W by 4. Yeah, 5W by 4, right? Then what is the next thing that we have to find? No, I will erase other parts. Okay. Now we have to find this x and y separately. We have to find that. Okay. So then now let's consider rod AB and apply equilibrium of forces along the vertical direction, okay? Or by considering vertical equilibrium. Okay, when you consider vertical equilibrium for this rod, how it is balanced. Okay, total upward forces R1 plus that Y, that must get equal to this W, right? So then what is Y? Y equals W minus R1, and that is the only force, right? So R1 we know 5W by 4, W minus 5W by 4, that means minus W by 4, right? Minus W by 4. Minus W by 4 means now actually that vertical force that I have marked over there, Y, right, is positive along this direction, right? That is the case, right? Okay, so it doesn't matter. So now we know what is the component, what is the value of the component of Y, right? That means actually when you are going to consider this rod AB, right, the Y is actually along this direction, which is W by 4. Okay, this is Y. Right, so then what is the next thing? Now we have to find what is X. Okay, so now let's find what is X, right? Because now we have to find the value of this force X, right? So then I will erase this part again, right? Right. So then now here the problem is actually now the reason now when finding the value of this force X, right, there is another guy. What is that guy? There is a tension, right? This tension also we don't know, this X also we don't know. Understand? That is the point. So that is why when we are going to consider the horizontal equilibrium for this rod AB, then it will not be possible for us to calculate what is the value of the force X, right? So the only possible way is to consider moment, right? Consider moment equation for rod AB. Consider moment for rod AB, but at the point, let's say this point is D, this point where the string is connected, right? At the point D, that is the only possible option, right? So now we'll take moments about the anti-clockwise direction for the rod AB at the point D, so MD. So when it is balanced, the total moments must be 0, right? So then how to get that? So we know we have this force X, okay? So X into the perpendicular distance is what? A cos alpha is sin alpha, right? X times A sin alpha, right? X times A sin alpha. Then we have Y, that is also going in one direction. See, X going in counterclockwise direction, this Y also going in one direction, counterclockwise direction, right? So then plus Y times A cos alpha, right? Then what else? Now we don't have to worry about W. Why we don't have to worry about W? Because now we have taken moment about the point D, so don't worry about W. And the next thing we have to worry about this R. The R, that is going in clockwise direction, right? See, it is going like that now, right? The moment generated because of this force is clockwise direction, so the perpendicular distance will be A cos alpha, right? Minus R1 times A cos alpha. So and that must be 0, right? So now let's solve that. Okay. Now here A we can cancel, right? Agree? So then we have X sin alpha plus Y cos alpha equals R1 cos alpha. Agree? When simplifying this, now see guys, there is a problem that I want to tell you, right? Now see, X sin alpha plus W by 4 cos alpha equals 5W by 4. Then be very careful, this is a common mistake. Then we know that X sin alpha equals, see, W divided by 4 cos alpha equals 5W divided by 4 cos alpha. That means if you simplify these two guys, right? On this side you will be getting pi w by 4 cos alpha minus w by 4 cos alpha, right? So then no doubt that you have written w cos alpha here, okay? But be very careful, right? Be very careful. Now here we have considered the moment at this point D, right, due to this force, due to this reaction Y, by considering along the direction that you have already sketched the force, right? Understand? So now actually you have sketched the direction of this force along this direction, right? So be very careful. Along, now if you are going to consider for this rod, along this direction the value of Y is what? That is the thing, right? So along that direction the value of Y is minus W by 4. Got it? Understand? Right? Okay. So now you have taken this counterclockwise moment for this rod about the point D because of this force along the direction that you have already considered during this diagram, right? So but in this direction this force is minus W by 4. Agree? So be very careful here. If you have substituted W by 4, then that is the wrong point. Or you could have again changed the direction and considered that direction. Then you can again change the direction by putting this direction of Y to downside. Or if you are going to take it like that, don't put W divided by 4. Then you have to put minus W divided by 4. Right? Okay. So that is the way. I hope you got it, right? So in that case, now we know that it should be, right, because of the original direction, then it is x sin alpha minus W divided by 4 cos alpha equals 5W divided by 4 cos alpha. So then now it will be, if you take this to other side, 6W divided by 4 cos alpha equals x sin alpha. So then x equals 3W divided by 2 cot alpha, right? So that is how you should solve that. 3W divided by 2, 3W divided by 2 cot alpha, right? So now, but if you are going to consider the value for that was, now see, that is positive along that direction. Okay, now I will erase this guy. Okay, now I will erase this guy. Now see, we know if you are going to consider this joint x along this direction, that is x. What is the value? 3W divided by 2 cot alpha. This one, we know along this direction it is negative now. So now worries, right? Let's sketch Y like that. What is this? W divided by 4. So what is the resultant? Huh? So what will be the resultant? If x is going like that, if y is going like that, then resultant will be something like that. This angle is let's say phi. Okay. So what is the angle? What is this angle? Then the resultant makes it the horizontal axis. That angle phi equals tan inverse y component divided by x component. You know, then the angle phi will be tan inverse y divided by x, right? Tan inverse, what is y component? W divided by 4. X component 3W cot alpha divided by 2, right? So that means this 2 to this 2 you can cancel, right? So this 3 will be there. That means 3 into 2 6, right? Cot alpha goes up, will become what? Tan alpha, right? So the angle phi will be tan inverse, okay, tan alpha divided by 6.